I was talking is, if you consider, I was talking about the decay constant. Now this lambda is different for different elements. I told like uranium has small value, thorium has small value, polonium has small value, radium has, because it is different. Okay, this after a particular time, how much number is now remain? Initially, inside the uranium, this much 100 was there. Now after 4 years, how much is remaining? Now how much is there? That one I can find using this equation. That's what we are using this equation to find. N is equal to n naught into e to the power minus lambda t. Where n naught is the initial number, lambda is the decay constant, times the time taken. Any particular time we can put. N is in that particular time, how much is there, that is being given by n. Okay. So there are so many cases, so many times we can discuss, but particularly we are going to discuss a time that we call half-life. Okay. So now I will derive an expression for its half-life. Now, half-life means what? Half-life means the time taken for its initial amount to become half of its value. Now, initially there is n naught means now the value I can put n naught by 2. Okay, n naught into e to the power minus lambda into t half. Now I have to find an expression for t half. So t half means what? That initial number, that one should become n naught by 2. But I think you can understand why we put n naught by 2 here. What is the same? When I put a particular time, after that time, how much is remain? So t half means what? T half I know by definition. The number in order to become half, how much time it takes. That means n naught in order to become n naught by 2. Now, what I'm going to do is I'm going to simplify this expression and I'm going to get an expression for t half. Okay. So how to do that? So normally they don't ask this derivation if you know the final equation in us. So you can see I can cut this n naught and n. Then there will be half here. I can take this 2 up. 2 to the power minus 1. That is e to the power minus lambda into t half. Then minus will go 2. Then what I can say is 2 is equal to e to the power lambda into t half. Then I can take to the e to the base. Then ln to the base c2, that is equal to lambda into t half. Therefore, this when you tell using the natural logarithmic table, if you see what is the value you will get is 0.693. That is equal to lambda into t half. Therefore, t half is equal to 0.693 divided by lambda. If you round it off, 0.7 divided by lambda. That is t half. So this is one expression. This is the relationship between half-life time and decay constant. Okay. So if you know the decay constant, that means if you know the decay constant for any particular element, uranium, thorium, polonium, radium, or lead, and if you know the decay constant, you can calculate the half-life. How did I get the expression is you can derive. This is some important derivation. No, in this derivation, there is no differentiation or integration. So they can ask. Okay. Here see n means n naught by 2. Then n naught and n naught I am cutting. That's half. Now this 2 I am taking up 2 to the power minus 1. E to the power minus lambda into t half. Then minus will get cancels off. 2 is equal to e to the power lambda into t half. This c I am taking down. Then log ln 2 to the base c is lambda into t half. This logarithmic table, natural logarithm, the base c, not to the base 10. Then that value, if I say 0.693, that is lambda into t half. Therefore, t half is equal to 0.693 divided by lambda. Therefore, t half is equal to 0.7 divided by lambda. The thing is, now we calculated an expression for t half. Half-life time is equal to 0.7 by lambda. That means for a particular element, half-life is constant. From this, what you can come to a conclusion is for a particular element, half-life is constant. That means uranium means half-life is only 1. Right? Because here see half-life time period, the expression is 0.7 over lambda. No, 0.7 is a constant, isn't it? And lambda we call as what? Lambda we call as decay constant. That is for a particular element, that is 1. That means uranium half-life is 1. That means thorium has another half-life time period. For different elements, there is different half-life. For a particular element, half-life won't change. It is always a constant. Because half-life depends on what? Using the equation, you can come to a conclusion. Now, in physics, if they're given one expression like that, this depends on this particular this means you can think about the equation. What does it depends? Using the equation, you can find. So similar t half for a particular element that has one value. So what is the unit of lambda? sometimes they can answer. Now you know lambda we can write as 0.7 divided by t half. T half is time normally second, isn't it? That therefore unit of lambda is second minus now. Normally they give like in the calculation, let's take lambda is 500.
Excuse me, miss, can you accept this? Because in my phone there is no charge. I have joined through my tab. Can you let me in?
Accepted, no? Sounds like it's joining. It is telling joining like that. Okay.
Okay, miss, I'll leave in this. Hold on.
Okay. Hello. Okay.
Miss,
Yes. Okay, Nona. You change the device. Hello. Shall I continue? Mic issue, no?
Miss, can you hear me?
Yes, I can hear you now.
Miss, can you hear me now? Miss?
Hello? Yes, I can hear you. Hello? Okay.
How long do we have?
I will finish this and this half lifetime period. Okay.
Okay.
Now, what expression we derive is T half is equal to 0.7 divided by lambda. Okay. Now, now sometimes they may ask questions like this also. Now, initially, there are n naught in a particular element. Okay, there's n naught number of molecules. Now, it is n naught by 8 after a particular time period. Initially, it is n naught after a particular time period, n naught by 8. So, how many half-life cycles has been taken place? So, half-life cycle means what? Initial amount in order to become half a particular time. So, initially, what happens means n naught, it goes to what? N naught by 2. And after that, n naught by 2 is half. N naught by 2, it goes to n naught by 4. Then after that, n naught by 4, it goes to n naught by 8. Then how much? There is 1 here, 1 here, 1 here. There are 3 half-lives. Okay? So, there is a way to find another way also. So, if they tell like other way, if they ask, you see, if there's n naught by 8, how many half-life cycles? N naught goes to n naught by 2, that is first. Then n naught by 2 goes to n naught by 4, another one. N naught by 4 goes to n naught by 8. Up to this, you must write. Or else sometimes they can ask other way around. Initially, there is n naught. It involves like 3 half cycles. So after that, what is the amount also? Then you can write 3 times and finally write n naught by 8. Did you get that?
Yes, Miss.
Okay. Then there's a small graph in this one. Okay. So half lifetime, we can depict it in a graph. So number with time. Okay. So normally it takes infinity time for every molecules, you know, that uranium, thorium, every element. So yeah, every uranium, thorium, polonium, radium, radon. That means half life we are talking. That means n naught in order to become n naught by 2. That is one half life. T half. We can mark it in a graph. Then n naught by 2 in order to become n naught by 4. That is half-life. Half-life is always constant of a particular element. This is 5 minutes means this is 5 minutes. Let's say this is for uranium like that. Any element, half-life is always constant. That's why I told T half is equal to 0.7 divided by lambda. It only depends on the decay constant. Next is what? N naught by 4, it goes to N naught by 8. That is a T half. Similarly, N naught by 8, it goes to N naught by 16. So we can depict it in a given diagram. Okay. The important thing you must remember here is the life of any radioactive nuclei is infinite. We can't tell. That means uranium means I can't exactly tell. Within 5 years, it will completely decay and finish. That is the problem in radioactive elements, not like chemical elements. It will take infinite time. That's why the graph is approaching infinity. You say that Tx is the life of any radioactive nuclei is infinite. It is not, we can't predict. Okay. The half-life time, if they ask like a definition, define half-life, you can write as the half-life of a radioactive nuclei is the time taken to half the nuclei present to disintegrate. Half-life means it is like getting decreasing, you know. So that we call as this. Then another there's an equation we call as activity. There's another thing we call as activity. Activity is now similar to n is equal to n naught into e to the power minus lambda t. There's an equation. A is equal to A naught into e to the power minus lambda t. There, similar to this equation, A naught we call as the initial activity. This is the activity at a particular time. This t can change to t is 4 days or something like that. And another thing you should remember, when doing calculations, they make mistakes. Here see, now this lambda into t. Okay, now in physics, earlier starting days you would have studied any power. That means resultantly it can have dimension. If they give lambda unit of lambda is 5, let's say unit of lambda is second minus 1, then this time you should write it in seconds. That is, if they give a calculation 2 minutes, don't directly substitute 2 minutes. Careful now. They make the mistake now in this. Let's say this substitution, you are getting to substitute a particular equation to find something. N is equal to n naught into e to the power minus lambda t. Now, if they give lambda is 500 second minus 1, this t should be in second. Then only second minus 1 and second get cancels off and the power doesn't have unit. So both should have particular unit. If lambda they gave in day minus 1, is it 50 day minus 1? Then time also should be in days, 2 days. Okay, careful now when substituting here. When substituting in this equation lambda into t, if t is measured in seconds, lambda should be second minus 1. If they give lambda second minus 1 and if they give like t is equal to 2 minutes, so to convert it to 120 seconds and substitute. Did you get that point?
Yes, miss.
Okay, so that's it. Okay, you can leave it. Okay, right? Any doubts?
Miss, can you teach me that E is equal to MC square? Can you teach me a question in that?
Okay. How to substitute and get the answer?
Yeah, I have some doubts in that. I don't know how to do that question properly.
Okay, I'll give a question. When is your exam, physics? May?
May 4.
May 4.
Miss, how do you do paper class? How do you teach that? Do you like teach the past paper or do you like correct?
We normally do past papers.
Sorry, Miss, I didn't hear you.
Yes, past papers only I normally practice. If you have
Can we
extra
do
time,
a-
you can try model questions also, no? What? Hello?
Yeah, can we do a class tomorrow? A past paper
Past
class?
paper. Okay. Can you send that paper which you want to discuss earlier?
Okay.
Then I can go through it and write the answers and I can discuss, right? You have papers, right? Which you have doubts and everything.
Yeah.
Physics, right?
Yes.
Okay. So let's do a question in E is equal to MC square. So E is equal to MC square. So the question is 1 kilogram of uranium. Okay, 1 kilogram of uranium atom. When it is undergoing a radioactive decay, it releases. Okay, it releases 8 into 10 to the power 13 joules. Find the mass loss. So this E is equal to MC squared. When you are doing the calculation, this is not the mass. It is the mass loss. Okay. The thing is, there is an element. Okay, uranium is there. 1 kilogram of uranium is there. So what does it doing is it start to decay, right? This element is when it start to decay, it is releasing this much of energy. 8 into 10 to the power 13 joules energy. A particular time period we took and it is releasing this much energy. They are asking find the mass loss. That means now I'm going to use this equation. E is equal to mc squared. This E is the energy released. So which is 8 into 10 to the power 13 joule. M into this C is what? C is the speed of light in air, which is 3 into 10 to the power 8 whole things here. Therefore, M I can calculate 8 into 10 to the power 13. This we are now 9 into 10 to the power 60. That is 8 over 9 into 10 to the power minus 3 kg I get. So this we call as what? This we call as the mass loss. That means no need to consider 1 kilogram here. So directly this E is equal to MC squared, but M gives the mass loss directly. So what you calculated as M is the mass loss due to this reaction. Now you get it?
Yes, miss.
Okay, write down this. Now in this radioactivity, how the energy is being formed is, I already told you, energy can't be formed. Energy can't be destroyed. Always one form of energy is converted to other energy. That's what we are talking in mechanics, also dynamo, motor, and everything. But this energy is converting into this energy. Kinetic energy is converted to potential energy. We never talk like energy is created, energy is formed. Then what does here this happening is, here in radioactivity, Albert Einstein, what does he thought is, he is like in his model, he is but explaining mass is an energy. So this mass is being destroyed. That is, mass energy is being destroyed, and that energy is only released 8 into 10 to the power 30. Mass is a form of energy. Considering in a concept like that, it's a little bit different concept. This radioactivity is it's a different lesson from other lessons of physics. Normally, we don't consider mass as energy in any lessons of physics, okay? But here, E is equal to mc squared. The concept is a different one. It's a different theory. Like normally science also they told like astronomy and this radioactivity and everything. It's like a different like concepts like that. Okay?
Yeah. Miss, can you
Okay,
teach me A is equal to lambda n?
which one? V is equal to?
So A is equal to lambda n.
Activity. Yeah, that is
Yeah.
similar to that. Now, we study the equation like this. So, dn by dt is equal to minus lambda into a. And we studied an equation. N is equal to n naught into e to the power minus lambda t. Similar, I told you the equation A is equal to a naught into e to the power minus lambda t. Then, similarly, A is equal to lambda into n you can write. Instead of this dn by dt, you can write n. Okay? This n1 was something like that. So what is this A is equal to lambda into n? What does it implies is, now both are different. Now dN by dt is within the time it is getting decay. Now, using the formed energy, now when a reaction is happening, okay, when a reaction is happening, what is happening? In a mass is being lost and energy is released. That energy we can use for some other thing that we call as activity. Okay, when we are using that energy here, lambda we call as what? Decay constant. Okay, and n is the number of nuclei present. Involving a reaction. So if you want, so have you done sums in that equation? A is equivalent to lambda n.
No, Miss, I'll do it tonight.
So they give like in a certain element, there was a question, in a certain element, they gave like activity is 2 into 10 to the power 10 second minus 1. And there are 6 into 10 to the power 20 nuclei present within the element. Calculate the decay constant lambda. So A is equivalent to lambda n. So you must know to calculate the equation. They gave like in a certain element, the activity is 2 into 10 to the power 10 second minus 1. Okay. Inside the nucleus, how much of number is present is 6 into 10 to the power 20. Then calculate lambda. So when you simplify, you get lambda is 1 by 3 into 10 to the power minus 10 second minus 1. Similar to this. Yeah, that means n is equal to n naught into n is equal to n naught into e to the power minus lambda t. We are talking when it is being decayed. A is equal to when it is being decayed, energy is being released. Using that energy, a reaction is happening that we call as activity. The SI unit of activity we call as Becquerel. That also you should remember. Okay, activity has an SI unit Becquerel. You know that, right? Sometimes they ask in the questions.
Yes, Miss.
Okay. Hello.
Yes, Miss.
Okay. Then shall we continue next class then?
Miss, so we did 3 class, right?
No. 2 classes. Chemistry, no? Chemistry 1 hour, and physics 1 hour, 1 hour. We split it and did.
Yeah.
Right?
Okay.
That's right.
Yeah.
Okay. In next class, you want to do papers, right?
Yeah.
Papers means which one? Full paper.
Full paper.
Okay. Then you send me the like years. You can send me the paper. Or you send me the years. I can download it from the net, right? Anything is fine. Okay. Okay.
Thank
Then.
you, Miss. Bye.
Bye.